Hello, everyone. This is Donijan E. Abera, leader of a group of third year mining engineering students from St. Paul University, Surigao. And today, we will be discussing about the analysis of gold. Let me first introduce to you the objectives of this report. At the end of this lesson, students shall be able to first describe what is gold and the mining processes associated with it. Second is to explain the techniques in refining and analyzing gold. And third, which is probably the most important and the sole purpose of every lesson that we are trying to learn. Of course, we need to assure that we are going to apply the learnings in real life settings for our future mining career. And now let us proceed to the description of gold. So, what is gold? When we say gold, it is very common for us. We often associate it with jewelries like necklaces, our earrings, rings, bracelets, etc. But yeah, gold occurs in natural state. So when we say natural state, we all know that gold is a type of native element or native or wherein a native element means that it occurs naturally. It is not combined with any other mineral, and it has a distinct mineral structure. And when we talk about its physical structure, when gold is soft, actually um, we might be confused about this because gold is used for jewelries, but yeah, gold is actually soft. That's the reason why there is no jewelry with a 24 karat content of gold. We often observe that it is only 18 karat gold, 14 karat gold. It is because if it is a pure gold or a 24 karat gold, it would be very soft. So it is not ideal for that intended use. So gold is actually a pure gold is actually soft. And in terms of its color, we all know the color. It is bright yellow. It is corrosion resistant element and it shines. Yeah, gold. See, that's the reason why it is very ideal for jewelries, and it is also one of the most malleable and ductile metal. When we say malleable, meaning it can be pressed, it can be hammered, it can be extended, or it can be shaped without cracking or breaking. And gold is also a good conductor of heat, electricity, and a good thermal and electrical conductor. And very important thing is that it has a melting point of around 1065 degrees Celsius. Its atomic number, which can be found in the periodic table of elements, 79, and its element symbol is Au. And now let us proceed to the mining and processing of gold. So, in terms of mining, gold can be extracted by both surface and underground mining. And of course, it has different types or it has different methods that is basically dependent on the factors that affects the area. It is basically the geological structure and geological condition and the other important factor to be considered during the mining operations. And in terms of mineral processing, the crushing and separating of ore into valuable or waste by any means a variety of techniques. So this is the most important part of this lesson or in this report, because today we will be explaining and discussing to you the techniques that will be used or are commonly used in extracting gold. So bear with us until the end of this discussion.
Techniques in refining the gold. The following are the four techniques in refining the gold. First is inquartation, second is scarification assay, third is bullion assay, and fourth is solution assay.
Good day, everyone. I am Maria Elizabeth Hernandez from Group 4, and I am assigned to discuss the inquartation. Inquartation is one of the techniques in refining gold. So, in inquartation, sa assaying is mag-a-add ka ng silver sa door or silver gold alloy with boiling nitric acid para mas mapadali and effective yung process of parting. Then by melting with the right proportion of copper and silver, granulating the melt to form a high surface area, and then with treating of nitric acid, the gold in the refinable material is matutunaw siya for about 25%, and that's literally quartering the gold. The silver and base metals is madidissolve siya sa acid. Then, yung naiwan na lang bali is yung gold. So, ang ibig sabihin is, yung gold is parted na or separated sa silver and sa base metals during the acid process, which is known as parting. So, the dilution of gold is required siya and important para yung nitric acid is mag-react and magtunaw ng mga base metals and silver that some of which may be nakahalo sa gold. Inquartation also is the practice of making a button that is 1/4 gold, and gina-practice na ni siya for many years sa pag-assay and sa pag-refine. In order for the fire assay of precious metals, kailangan ng collecting agent na mag-assist sa parting process. So, yung small amount ng silver is, di ba ginabutang na siya sa crucible during sa pagmix ng mga fluxes. And there has to be a ratio of 3 silver is to 1 gold for the parting process para makaproceed siya and mag-work yung parting. So the reason why ang parting process has to follow the ratio of 3 silver is to 1 gold kay if ang ratio ng gold is higher than silver, yung silver is di agad-agad siya matutunaw gamit yung nitric acid kasi magkukos lang siya nung pagkasira ng bead. So if that's the case, failed yung parting process. Terms in inquartation. Door. This is simply the mixture of silver and gold, and a product of fire assay after cupellation. Parting. This is the process of separating silver and gold with the use of nitric acid. This eventually, the silver dissolved while the gold bead still remains. Weighing. This is a step sa assaying so that ma-determine nato ang sample which helps to produce a normal size button, and at least up to 0.00001 gram accuracy measured by analytical balance, which is the most accurate. Cupellation, and this is a step to separate the lead from the door by treated under a very high temperatures or oxidation and subsequent absorption of litharge in a cupel. A decantation. It is the process of separating insoluble solid particles sa liquid or separating two immiscible with different densities. The purpose of this is para ma-obtain either a clean decant or separate the two unbinding liquids. Cupel. It is an equipment na ginagamit sa cupellation process. It is flat, shallow, crucible made of bone ash, cement, or other materials, used in assaying as for separating gold and silver from lead. The outline of the inquartation and parting refining process. So to explain this flowchart, advantages that this technique inquartation has over the aquaregia process is mas simple ang operation kung saan yung the loss of gold should occur while yung mga base metals, silver and palladium na natunaw out of the refinable grain, leaving all the gold behind is nandun pa rin siya sa original form ng grain. And then the equipment is pwede siyang gawin sa stainless steel na mas durable kaysa sa glass. And yung nitrogen oxide evolve which has to be dealt habang yung solution na form sa last process na may nitrates can be treated para ma-recover yung silver and palladium. Then, leaving all base metals nitrates for disposal.
Good day everyone, it's me Joan Rodriguez and my part is in the inquartation on how it is done steps. So, cupellation. Cupellation separates the gold and silver from the lead or separates impurities by melting the impure metal in a cupel, or we can say bone ash cupel. These bone ash cupels have been used from time immemorial to absorb litharge and accompanying oxides in assaying. So as you can see in the pictures, amo dyan ang cupel. And then, amo dyan ang kuan, painiton bitaw. Dira sa dibutang katong gold and silver para dira magpahilis. Ganun. So, ang ikaduha is sort and weigh the karat gold. So, in this part, after the cupellation process, timbang na yun to siya. Tapos, ang taong na yun tong, i-remove na yun nato tong silver using the solution nitric acid. So, in this part, may bayan na yun nato kuan, yung pure gold, ganun. So, sa pag-measure ng purity of gold, ang tawag dyan is caratage. So, pag 24 carats gani, ibig sabihin dyan, pure gold good na siya, way other metals na nasagol. Pero kung low carat sa good siya, ibig sabihin na contains yung less gold. Fineness in another way of expressing the precious metal content of gold jewelry and represents the purity in parts per thousands. So, ibig sabihin ng fineness is yung purity of gold. So, as you can see in the table, di ba kanang 24 carats, 22, 21, 20, 18, 15, 14, or 10. Tapos yung mga gold content nila or degree of purity. Amo dyan yung kuan ng golds kanang pure ng gold hangtod sa purity ng gold na walain sa gold na metal hangtod sa pababa, which means may mga kanang less lang ang gold nga na. So, di ba ang ganyan is 24 karat man pinakataas, which means pure gold good na siya, way good sagol na lain metal. So, ang ijag degree of purity is 99.95 plus %. So, kita naman sa table, 91, 22 carats, ingana. So, pag 18 karat gold contains dyan 75% gold and 25% other metals. So, pareha dyan siya na contains siya na example, copper or silver. Sa ikaduha na table, dyan diri yung yellow gold, white gold, and then rose gold. Makita niyo mo kung pila cartridge, tapos kung ano yung mga umay na mga nakasagol dira sa yellow gold, white gold, o rose gold. Example sa pareha ng gold, silver, copper, zinc, or palladium. So, just like what I said ganiya sa pinakauna na table, di ba? Example yung pagdya caratage na 9K, ibig sabihin dyan gamay man siya, so ibig less gold ra na siya. Tapos yung pinakadako na sa gold dyan is silver, nagsunod ra ng gold, tapos din copper nga. So pareha sa ibang pod nga na kanang ibig sabihin na ra sa table is, and then the more metals are mixed with gold, the lower the carat becomes. So, amo dyan siya, yung saying napakita, may mga 9K, 10K, 14, 18, and then 22 carats sa ilat to you. So, a higher carat size means a higher price. Ano aragod ka na, pamakita ka nan, kintahi, di ba? Example ka, makita ka nan, mga sa sing-sing, di ba? Gamay ra na siya, pero dako na siya carats, So, the carat is not the size of the diamond kuno it is the weight. Biski gamay yun na siya, pero yung timbang niya bugat, mahal jud na siya. Then, inquartation. Inquartation is the addition of silver to a gold-silver alloy in order to facilitate the parting of the gold by nitric acid. So, inquartation method is one of the most common method of refining low and medium carat gold. So, pag mo-inquart gani, Di may good ko ana para sa gold dili siya pwede in-quart tungod kay kuan man gud siya low in silver content. So kailangan pag ato siya in-quart sagulang gud nato siya ng silver. Kay pag low silver content ra ma-dissolve man gud ang gold bitaw sa aqua regia pag ato ibutang. So pag high silver content mukuan man siya kanang mo-form man siya ng layer of insoluble silver chloride which is amo dyan ang protect sa gold from aqua regia. So unsa kailangan gud nato i-add nan adan ang gold nan silver. So in quarting it is needed most when refining yellow or green gold jewelry due to their high silver content. Although white and red gold jewelry contains little to no silver, this should still be quartered due to the high base metal content. So katabi taton ganiya sa table. Sa ikadwa na table to, katong may white gold, yellow gold, and then rose gold. Magata nato dituan na ang silver jud gamay ra na siya sa white ug rose gold. Daghan siya didto sa yellow gold. So unsa amo taglaw na kung dako yung high base metal content kailangan gud nato siya in-quart. So in general yung dissolving base metal with gold will add steps to the refining process and consume more chemicals. So ibig sabihin pag the more na daghay bitaw base metals yung isa ka gold, the more na daghay process yun ang mahimo. Amo dyan tagloong pa na aton ganihan na kaupat bitaw kanang nitric acid then butang sa tubig ulit na sab sa tubig ngana. So makita ra man nato gud kung ano mahitabo sa color bitaw sa pag in-quart nato sa gold ug silver. So di ba kung pag white siya ang muto nga yung white, then muto nga siya greenish yellow. So pag-ana ang amount ng sit ng gold is taas na dyan na siya. And then bright yellow. Yan. Number 4, the resulting bed is cleaned and dropped into nitric acid or parting. So the parting is effective in a test tube or a porcelain crucible if the bed is small. In a parting flask if large. So depende na gud katayon nimo ibutang ton ako hayon ka magparting ng gold. And then nitric acid of specific gravity is 1.25 made by adding 3 parts water to 4 parts of ordinary strong acid. Is suitable for use with all beds. There is no advantage in using more dilute acids for poor alloys. So pag nakakata ka mo na katong video bitaw na mag-video ka so ya man diri. So sa video man gud kita pakita kay yung gold tabutang siya sa yung gold na may silver tabutang siya doon sa nitric acids, and then sa nitric acid na dissolve na yung yung silver natangtang na napabilin na kan is yung gold, tapos tabutang na lang siya sa tubig. Pagkatapos sa tubig parang nanggahi bitaw siya, tapos sa yung ulit na siya tabutang na siya sa sa butro nitric acid ganun. Tapos sa tagbutang sa tubig tagbalik-balik ka bitaw hangtod ko na makakuha na bitaw makita ganin mo yung pure gold na bitaw yung hinlo na siya. Then the freedom of nitric acid from chlorine is ensured by adding to it a little spent acid containing some nitrate of silver. Kaya ka natin sa video na tabutang na sa silver. Then in all cases, the acid must be previously heated to boiling, as the gold does not, in that case, break up into such fine particles as if cold acid is used. So, syempre, kailangan magulod hot na pa? Iton hot nitric acid sa hot nitric acid ni ibutang kay tungod di man gud ma-break up pag ra tignaw ra. Mugahin nun ba pag-isa nato. So, ang purpose man gud ng kuan hot nitric acid kay it is to dissolve the metals tapos ang silver from the kuan para mahiwalay siya sa gold. And then ang nitric acids di man gud siya mo dissolve na sa gold, tapos yung gold mabili na siya behind sa kuan sa nitric acid, tapos yung silver amo yun mawaya. The acid eats into the pieces of inquartated gold, forming a honeycomb structure inside the gold as it progresses inward. So, ang tagla na kung mabili na bito sa kuan nitric acid yung gold, maporma man gud na siya. Then, if done properly, the pieces of gold will retain their original shape, appearing smoother because the base metals and silvers are gone. Oo, hangtod makagamay bitaw siya. Kuan katungod wala naman ang silvers, tapos yung base metals. Nahilo na ba siya yung ato? Number 5, melt the gold into a button. So, di ba after nitric acids, ato daw i-transfer yung kuan wet pieces of gold to a milk dish and begin to melt. So, yung gold melt nato, it's been refined with aqua regia. And then, pagkatapos, di ba ato man tag-init-init, dito siya tag-melt. So, hangtod magkahilis-hilis na siya, butangan na to siya kuan tiny pinches of potassium nitrates. And then, pagkatapos, kayadyuhan na sab. Pagkatapos, tangtangan na sa dang kayadyo pagkatapos na itong magpahilis. And then, yun, sakto na bitaw na pagkahilis. And then, yung borax, butangan na to para ma-freeze yung gold. Ama na nagto. Pag kuan na to, maduga dyan, mabuo na dyan yung gold. Tangtang na siya sa butangan, tapos buta sa tubig. Amo na, makita na nato yung nice button of pure gold na dyan.
Hello everyone, my name is Christine Marie Picante and I am going to discuss about scarification assay. Scarification assay. So it is a process in assaying that involves the use of a scarifier, which is a small bowl-shaped cup. So with this process, nag-consist siya ng oxidizing fusion or other product na naay lead and borax in order to produce a slag. And we all know that slag is a stony waste matter. And then, ang gold and silver is mabilin sa lead button. In other words, scarification assay is simply a process where the gold or silver is being separated from ore by fusion with lead. So next to be discussed is the definition of terms. First is the scarifier. So it is a shallow open-mounted dish that is about 2 to 1/2 inches across. Very thick ang ija bottom part and amon ni ang gamiton para ma-separate ang gold and silver sa slag. Next is flux. It is basically a flowing agent that promotes fluidity, and by using this substance, it makes the compounds na dili ma-melt into compounds na dali na ma-melt at a certain temperature. Next is acid flux. So basic sample require an acidic flux to produce an ideal slag. So examples of acid flux are silicon dioxide, phosphoric acid, and hydrogen chloride. While basic flux is acidic ores needs a basic flux to produce an ideal slag from the resulting fusion and in turn produce the best results. So ang examples for this are lime and magnesium oxide. So the difference between acid and basic flux is that acidic flux is added to molten metals to bond with basic impurities that can be readily removed, while basic flux is a substance added to molten metals to bond with acidic impurities that can be readily removed. In short, acidic flux is for basic impurities, while basic flux is for acidic impurities. Next is borax glass. It is a strong acid flux and it is the most widely used flux in all fusions. Next is muffle furnace. It is simply a furnace in which ang samples can be tested at high temperature. It is being used when high temperature is required and para dili sab magkakontak ang fuel with the material to be used. And last is cast iron mold. It is a commercial alloy of iron, carbon, and silicon that is cast in a mold and is hard, brittle, non-malleable, and incapable of being hammer welded, but more easily fusible than steel. So, scarification has 3 steps. The first one is sampling and fluxing. So, ang reagents or ang substance na tagamit para makakos ng chemical reaction are pure granulated lead and borax glass. And in this step, ang ore is being mixed with this mixture sa scarifier. As you can see in the table, ang proportion ng lead o borax will vary and should be greater. Dako dapat it is because ang gang and metallic oxides are more difficult to fuse. So in most cases, 1/10 of an assay ton of ore and 30 to 40 grams of lead will be found to work well. And sa process ng fluxing, ang ore and 1/2 of the lead mixture are being mixed in the bottom of the scarifier, tapos ang the rest of the lead are being poured over the mixture kay para maka-form ng cover. Tapos 2 or 3 lumps of borax, same as the size of a pea, is being placed on top. So after the sampling and fluxing, the next step is fusion. So in this step, ang charge is being placed in a hot muffle furnace and scarified. So sa diri na step, ma-melt ang lead, tapos ma-float ang ore sa surface. Tapos both are being roasted and oxidized. While ang basic elements, which is combined with the borax glass, tapos ang acid elements with the lead oxide, na-form sila into a slug on the surface of the molten lead. So, ang formation ng slug is magkaanam kataas hangtod makover na completely ang surface sa lead. So, the third step is the cooling or the preparation step for cupellation. So, ang charge na gikan sa muffle furnace is i-transfer dayon and is being poured into a cast iron mold, as you can see in the picture sa kilid. Tapos, i-allowed na dayon pag-cool. Ang lead button na usually nagasettle sa bottom part is being separated na from the slug, and then it is hammered into shape, usually into cube. Tapos ready na dayon for cupellation. So the following are the equipments and machineries being used in a scarification assay. Scarifier is being used in sampling and fluxing, tapos muffle furnace in fusion, tapos ang cast iron mold sa third step or the cooling process.
Bullion assay.
It's me, Denzel. Bullion assay. Bullion refers to physical gold and silver of high purity that is often kept in a form of bars, ingots, or coins. So, bullion assay is basically a test procedure of analyzing, measuring, and determining precious metals in metallic alloys. How bullion assaying is done. First is preparation of the assay piece, where the assay piece is flattened on a clean anvil by a hammer. About 3 grams is cut off with shear, then weigh the sample most accurately. Bullion samples are generally received in the form of chutes, borings, or mechanically prepared granules. Next is cupellation, where it separates gold or silver from impurities by melting the impure metal in the cupel. Next is preparation for parting. The assay button are flattened by a hammer on an anvil. A heavy blow is first delivered on the center of the button, and the 2 lighter blows are then given on the opposite side of the disc so as to elongate it, then rolled into cornets. Next is parting and annealing cornets. Parting is boiling with nitric acid in glass or parting flask, where the silver and gold is dissolved Then gold is separated to silver. Then the pure gold falls through the liquid and rests in the crucible. The crucible is dried and then annealed at a red heat over gas or in the muffle. Then the gold shrinks greatly through still preserving its shape, hardens and regains its ordinary pale yellow color. Then it can be now weighed. And the last step is weighing and reporting. The cornets are weighed on a most accurate balance. The check assay are weighed first and determine excess or deficiency in weight applied to all assays run with them. This correction is called surcharge. Methods in bullion assay. First is trial by touchstone. It rubs the gold bullion in a touchstone and comparing the appearance and color of streak with prepared needles of known composition. Touchstone is a fine-grained dark schist or jasper used for testing alloys of gold by observing the color of the mark which they made of it. Next is color and hardness of alloys. These properties form a guide to composition of copper-gold alloys. An increase of copper corresponding to the heightening of the color and can increase the hardness as tested by the shear or knife. On heating the alloy to redness in the air, the degree of blackening or the surface is a further indication of the percentage composition if compared with plates of known fineness. Next is density of gold-copper alloys. The determination of the fineness of these alloys by taking their densities was investigated by Mr. W. M. Robert Austin at the Royal Mint in 1876. He showed that the densities found by experiments were nearly equal to those obtained by calculation on the assumption that the union of the two metals are accompanied neither by contraction nor expansion. The alloy examined ranged from 160 to 1000 fine and were made into discs which were all compressed to the same extent. The conclusion arrived at was that the fineness of large masses of gold can be deduced from their densities correct to 1 over 10,000 part. In the case of individual coins, the results are only approximate. Lastly, assay by means of the spectroscope. This method of determining the composition of gold-copper alloys was investigated by Lockyer and Robert Austin. The spectrum of pure gold was shown to be altered by successive additions of copper, and near the English standard 916.6 fine, a difference of 2 or 3 parts in 10,000 in composition could be readily detected, but the amount of metal volatilized in a small that it could not be made to represent with certainty the average composition of the mass, which is never perfectly homogeneous.
Solution assay. Solution assay, which is with chemistry. Classical and analytical techniques including dissolution, titration, gravimetric analysis.
Hi everyone, I am Christine Macabenta. I will be discuss about dissolution. The next is about dissolution. Dissolution is the process where a solute in a gaseous, liquid, or solid phase dissolves in a solvent to form a solution. Solubility, the maximum concentration of a solute that can dissolve in a solvent at a given temperature. At the maximum concentrations of the solute, the solution is said to be saturated. Dissolution process is a process wherein isang substance ma-dissolve sa solvent. For example, sugar. Sugar, di ba, is solid. Sugar is a form of substance. So, example, ang sugar ibutang mo sa solvent. So, ang solvent is yan yung magtutunaw. Like example, tubig. So, ang sugar, pag ilagay mo sa tubig, di ba matutunaw yun. So, pag na-dissolve na yung sugar, makaka-form ng solution. Di ba ang tubig tapos sugar na tunaw naman to, wag na mix na siya. Ang sulyot ang tawag sugar, atong sulyot ang tawag sa sugar. Madissolve ang sulyot sa solvent, ang tawag sa process na yon dissolution. Tapos after ng process na yon, na-dissolve na yung sulyot dun sa solvent, ang tawag na dun solution. Gold by aquarrhea digestion/dissolution. In aquarrhea digestion, the sample is subjected to attack by a mixture of concentrated HCl and HNO3 acids. Aquarrhea is widely used in soil, sediment, and rock analysis as a partial digestion. Aquarrhea is the term used to typically describe a mixture of concentrated nitric and hydrochloric acids. So, familiar man ta sa gold, the metal. Ang mga metals, meron silang mga specific na mga solvent. Ibig sabihin, hindi lahat ng metal, iba-iba sila ng solvent kung saan sila magdi-dissolve. Kaya ang gold manggod, consider highest basta ko siya maganda yung quality niya o sa dili siya basta-basta na nadidissolve sa kahit na anong solvent lang. Ang solvent na para sa gold para matunaw siya is amodyon aqua regia. Next, gold by aquarrhea digestion/slash dissolution. Note, however, that this usage is not consistent with the ratios between the two acids being variables between different laboratories and research group. Because aquarrhea is not a total digestion technique, other factors in addition to the nitric and hydrochloric acid concentration and ratio influence metal recoveries. So, tapos diri sa picture, tagpakita ra diri ang content ng aquarrhea. So, ang content niya is dalawang substance, nitric acid, or yung merong chemical formula na HNO3, tapos yung hydrochloric acid or yung HCl na chemical formula. So, dalawa yung substance, yung content ng aquarrhea, yung nitric tapos hydrochloric acid. So, ngayon, hindi daw basta-basta mabubuo yung dalawa, dapat daw meron siyang ratio. Next, gold by aquarrhea digestion/dissolution about sa higher temperatures. Tapos diri nabanggit yung one of the most critical factors is the temperature. Once mas higher temperature, ibig sabihin i-heat up siya na mas taas ang temperature, mas mataas ang recovery, mas ang ija dissolution rate mas paspas na kay kung more temperature, ibig sabihin more heat, more kinetic energy na mag-drive sa mga atoms para mas mag-move sila rapidly, paspas ang process ng pag-dissolve or yung rate ng pag-dissolve. Kaya nga, pag mataas yung temperature, mas mabilis ang ija process. Tapos pag mahina yung temperature, mabagal yung pag-dissolve kasi kunti lang yung energy.
Good evening, everyone. This is Maria Elizabeth Chicaga. My assigned topic is all about the advantages of gold by aqua regia digestion dissolution. The advantages of the aqua regia AU method compared to PBFE include the following. Number 1. Lower detection limits compared to PBFE are achieved in many laboratories owing to the ready production of ultra-clean HCl and HNO3 via distillation and the advances made in inductively coupled plasma mass spectrometry instrumentation in recent years. Number 2. This relatively simple digestion method means that least technical training and experience for laboratory personnel is required than in the case for PBFA. Number 3. Small sample sizes can be analyzed for AU when analyzing the clay size fraction.
Gold by aqua regia, digestion or dissolution. So, limitations. First, for most samples, an aqua regia digest will not recover 100% of the EU in particular. EU occluded within most silicate minerals. EU, which means gold. So, number 2, large sample sizes for representative analysis for gold require special laboratory setup to maintain consistent heating and mixing across the digestion solution. So number 3, depending on the mineralogy of the sample, the total dissolved solid content can be high, as this method does not involve preconcentration and separation in the same way as the PB and FA method.
I'm Neljon Espinosa, reporting for the titration for Group 4. So, titration is the slow addition of one solution of a known concentration called a titrant to a known volume of the another solution of unknown concentration until the reaction reaches neutralization, so which is often indicated by a color change. So the use of titration is to determine the unknown concentration of an identified analyte. So, example, if ma-mix na ang hydrochloric acid, sodium hydroxide, sodium chloride plus water, if ma-mix na siya, so diha na ma-neutralize or ma-change ng ija color. So the solution called the titrant must satisfy the necessary requirements to be a primary or secondary standard. So in the broad sense, titration is the technique to determine the concentration of the unknown solution. So the purpose of this titration is the detection of the equivalent point. So the point at which chemically equivalent amounts of the reactants had been mixed. So if ma-mix na to siya, so dito na nimo ma-identified or ma-calculate nimo ang anong solution. Ma-calculate na nimo ang concentration acid plus yung isa volume base or uh, alagay volume base or a number of acid. So that's all.
Ang gravimetric analysis, it is a type of a lab technique na ginagamit na para mag-determine sa mass or concentration of a substance na mag-measure sa change in mass. Sa chemical nato na gitry na i-quantify ay gitawag ini sila na analyte. In other words, it is a technique through which the amount of an analyte or the ion ato gi-analyze can be determined through the measurement of a mass. An analyte, chemical species or component, mao sang substance or chemical constituent that is of curiosity in an analytical procedure. So next is the dissolution. So gold dissolution dili sida sadyo na ma-obtain sa mga acid. Gigamitan pod ini ng mga oxidant like sa manganese dioxide, nitric acid, oxygen, ferric ions or cupric ions na para mag-dissolve sa gold. Then, ang formation of the aqua regia, it is a mixture of the nitric acid and the hydrochloric acid. Then, it is a yellow-orange fuming liquid. Tapos, ginganlan ini sa mga alchemist kay tungod makadissolve sila ng mga noble metals like the gold and the platinum. Though na dili sila mga metals, no? The reason why it is because aqua regia na makadissolve sila sa gold and also the metals like mga platinum and palladium is that each of two component, which is the mixture of nitric acid and the hydrochloric acid, carries out a different functions. So, followed by the precipitation, it is the second step of the gravimetric analysis. So, di ba the first step is the dissolution na gidissolve ang gold gamit itong aqua regia. So, in the next step, it is the precipitation na ang gold na gikan na tag-dissolve ato na po di-precipitate gamit ang aqua regia. Then, na po ito mga chemical na ginagamit like ascorbic acid. So, after ito, it na change ang color then to na precipitate na kibali na gold nagsettle down o gamito na po ito sa step 3 or the next step. In step 3, it is the filtering and washing. So it is stated that it is crucial to wash the precipitate thoroughly to remove all absorbent species that would add to the weight of the precipitate. So it should be careful na paggamit sa water since part of the precipitate may be lost. And also, in other cases of colloidal precipitate, di pud ta magamit ng water as a washing solution since peptization would occur. So in the such situations, dilute nitric acid, ammonium nitrate, or dilute acetic acid kay gigamit. Then usually, it is a good practice na to check for the presence of the precipitating agent in the filtrate of the final washing solution. The presence of the precipitating agent means that extra washing is required, and the filtration should be done in appropriate size. So the step 4, which is the dry and ignition. So diba, the first one we have the dissolution followed by precipitation, and then third it is the filtering and washing the precipitate. So in the dry and ignition, meaning imo siday pamaya or painiton gamit ang muffle furnace. Kaya ining muffle furnace manggod kay naa siday high temperatures unlike the others oven. So meaning taas gud sila pressure or down pasok gud sila. Kay so amo to the purpose ng dry ignition of the precipitate is to obtain a compound of known and constant composition. So during this drying, the water associated with the precipitate is also get removed. So in the last steps of the gravimetric analysis, which is the weighing or ang pagtimbang, di ba katong sa step 4, which is the drying and ignition of precipitate. So ang purpose dianing step 5 kay kadtong mga gipang maya o ignite ng mga precipitate na gold kuan sila patignawon na para adisir sila timbang na para malikayan atong mga convection currents sa pagbag-o sa mga sukod sa mass. So mao ra na ang purpose ng weighing. So after the weighing is to calculate the results. So the result of a gravimetric determination usually is reported as a percentage of analyte. So percentage of analyte is equal to weight of the analyte over the weight of the sample and multiplied by 100.
And now we are almost done with the discussion, but before that, let me summarize first the topics or the lessons that we have discussed today. So, we have discussed about the analysis of gold, and we were able to describe or to define what is gold. So gold occurs in a natural state. It is soft, it is bright yellow, it is corrosion resistant, it is a good conductor of heat and electricity, it is malleable, and it has a melting point of 1065 degrees Celsius. So we have discussed also the techniques in refining the gold. So the first technique is inquartation, and the steps in performing inquartation is first the cupellation, second is sort and weigh the carat gold, the third step is the inquartation itself, the fourth step is the resulting bead is cleaned and dropped into nitric acid, or it is also called parting. And then the last one is melt the gold into a button. The second technique in refining gold is scarification assay. So the steps in scarification assay is first sampling and fluxing. Second is fusion. Third is cooling, or it is the preparation for cupellation. And the equipments that are used in scarification assay are scarifier, cast iron mold, and baffle furnace. Let us now proceed to the third technique that we have discussed. It is the Boolean assay. So the Boolean assay, the steps used in this process is first the preparation of the assay piece, second is the cupellation, third is the preparation for parting, the fourth step is parting and annealing the cornets, and the last one is weighing and reporting. So the methods in there are also types of methods that was discussed regarding the Boolean assay. So the methods are trial by touchstone, and second is the color and hardness of alloys. Third is the density of gold copper alloys, and assay by means of spectroscope. Then the next technique that we have discussed is the solution assay. So there are three types of solution assay that was discussed. So first is the dissolution, the titration, and the gravimetric analysis. And there you have it, everyone. You have reached the end of this presentation, and we hope that you guys learned something from us today. So, again, on behalf of Group 4, this is Donnie Ginabero. Thank you, and to God be the glory.